In this video, we will talk about session 9.1 sequences. First, we introduce the definition of a sequence. A sequence is an infinite list of numbers as1, as2, as3, and Sn, and so on. We call S1 the first term, S2 is called the second term, S3 is called the third term, Sn is called the nth term or the general term. Now we look at an example. We give a list of numbers 1, 4, 9, the n square. This list of numbers is a sequence, and its general term can be denoted by Sn is equal to n squared. This is an example of a sequence. So next, we do some simple examples. First example, give you the general term Sn is -1 to nth power. Then you are asked to give the first 4 terms of this sequence. First 4 terms. So the first term is when n is 1. N is 1, so it's -1 to 1. N is 2, -1 to 2. The third term, n is 3. The fourth term, n is 4. So get this is -1, 1, -1, 1. So this is the first 4 terms of this sequence. Next example. So give you a sequence, then you are asked to find the general term. Give a general term. So the sequence is this one: 1, 2, 4, 8, 16, 32, and so on. Although the first 6 terms do not determine the sequence, we can sometimes use them to determine a possible formula for the general term. So for this sequence, we see we have a power of 2. You see 2 is 2 to power 1, 4 is 2 square, 8 is 2 cube, 16 is 2 to power 4, 32 is 2 to power 5, and this 1 can be written as 2 to power 0. So the general term should be Sn is 2 to n minus 1, because the first term is 1. Right? When n is 1, you get 2 to power 0 is 1. So the general term is 2 to power n minus 1. This is the second example. Next example. Also give the first 4 terms of the following sequence. Sn is Sn minus 1 plus 3 for n greater than 1, and S1 is 4. So you see this sequence is defined recursively. That means its nth term is related to the n-1th term. So the nth term is determined by the previous term. So we wanted to find its first 4 terms. S1 is already given. S1 is 4. The first term is 4. So we have S2. S2, when n is 2, S2 is S1 plus 3. So it's 4 plus 3. This is 7. We have S1 is 4. S3 is S2 plus 3. So it's 7 plus 3 is 10. S4 is S3 plus 3. It's 10 plus 3. It's 30. This is the first 4 terms. Next example. Give a recursive definition. Of the following sequence: 1, 3, 7, 15, 31, 63. So now we observe this term. Each term is twice the previous term plus 1. For example, 3 is 2 times 1 plus 1. 7 is 2 times 3 plus 1. 15 is 2 times 7 plus 1. And this 63 is 2 times 31. 2 times 31 plus 1. So a recursive definition is Sn is 2 Sn minus 1 plus 1. For n is bigger than 1 and S1 is 1. This is example 4. Next, we introduce the concept of convergence of sequences. So the sequence S1, S2, Sn has a limit L written limit of Sn n goes to infinity is L if Sn is as close to L as we please whenever n is sufficiently large. So if a limit L exists, we say that the sequence converges to its limit L. If no limit exists, we say the sequence diverges. So finding the limit of a sequence is very similar to finding the limit of a function. All of the usual limit laws apply. Next, we review 2 sequences. They are of particular importance. So the first one is the sequence Sn is x to power n. This sequence converges to 0 if the absolute value x less than 1 and divergence if the absolute value x is greater than 1. The second sequence is the sequence Sn is 1 over n to power p. Its convergence to 0 if p is greater than 1. Greater than 0, sorry. So next example 5. Determine whether the following sequences converge or diverge. So the first one is Sn is 0.8 to power n. So this one, since 0.8 less than 1, so from this conclusion we have the sequence converges to 0. Convergence, and its limit is 0. So the second one is Sn is 1 plus -1 to n. So -1 to n, this sequence alternates inside. We already see at the first example. So we list the first few terms when n is 1. N is 1, -1 to power 1 is 1. So first term is 1 plus, first term is -1 plus 1, so it's 0. Second term is 2. Third term is 0, 2. So this sequence alternates between 0 and 2. Thus, we have the sequence Sn divergence. Since it does not get close to any fixed value, it alternates between 0 and 2.